In lesson 3.6, we're going to solve proportions using cross products. We have several vocabulary words in this section. Our first one is a cross product. This is just stating that the product of the numerator of one ratio and the denominator of the other ratio. A scale drawing is a two-dimensional drawing of an object in which the dimensions of the drawing are in proportion to the dimensions of the object. So this is just a drawing, it's two-dimensional. If it's a scale model, though, which brings us to our next section, a scale model is a three-dimensional model of an object in which the dimensions of the object are in proportion to the dimensions of the object. So you're actually building something that's three-dimensional. And the scale is the relationship between the drawings or the model's dimensions and the actual dimensions. We write this as a ratio, the scale measure to the actual measure. So our first box is the cross products property. What this property states is that the cross products of a proportion are equal. So in our example, when you draw this x here, you create these cross products, 6 times 10 and 5 times 12. Well, 6 times 10 is 60, and 5 times 12 is 60. Those are cross products, and we're going to be using that to set things equal to each other and then solve an equation. So in this case, right here in algebra, A times D is equal to B times C. And of course, because you cannot have 0 in the bottom of a fraction, B and D cannot be 0. So let's start example 1 by solving a proportion using cross products. So we have 5 over y equals 15 over 75. Well, 5 times 75 is going to be equal to 15 times y. When you multiply 5 and 75, you get 375, and y times 15 is 15y. And then you divide each side by the 15, which gives you 25 equals y. In example 2, we're going to write and solve a proportion. So our problem is, to feed your plants, you need to mix 3 tablespoons of plant food with 16 ounces of water. And I'm going to underline that to start with, because that's actually going to be one part of our proportion. If it takes 80 ounces of water to feed all of your plants, how many tablespoons of plant food are needed? To write a proportion, we have to set up 2 ratios that we can compare. The first one is going to be that part I underlined up there, 3 over 16. 3 being the amount of plant food, and 16 being the amount of water. On the other side, we're given that we need 80 ounces of water to feed all of our plants. So that has to go on the bottom with the 16. We have an unknown amount of plant food, which is x, that goes on the top. And then we will use cross products to solve that proportion. So it's 3 over 16 equals x over 80. So we're going to do 3 times 80 equals 16 times x. 3 times 80 is 240, and 16 times x is 16x. Then we divide each side by 16. 240 divided by 16 is 15. So you need 15 tablespoons of plant food for 80 ounces of water. So we have 3 checkpoints. The first 2 are to solve the proportion. So we're going to have 5 times 45 equals 25 times n. Five times 45 is 225 equals 25, and then divide both sides, 25n, divide both sides by 25, and you get that n equals 9. Number 2 is a little bit different from the ones we've done before, and you will have some examples on your homework like this. So let's pay close attention. You're still going to use cross products. So the 6 is going to be 6 times b minus 2. You have to make it look like that. And then we set that equal to 3 times b. So I distribute 6 times b is 6b minus 12 equals 3b. And then I have to take 6b away from both sides. That's going to leave me with a negative 12 equals a negative 3b. And then you divide both sides by negative 3, and you get that 4 equals b. And then in number 3, we're going to go back to example 2, and it says, suppose it takes 120 ounces to feed all the plants. How many tablespoons of food are needed? So we need to take that same beginning ratio that we had, which was 3 over 16, and that was tablespoons of plant food over ounces of water. And then we're going to set that equal to x over 120, because again, the 16 ounces was the water and the 120 ounces is the water. And then we'll use cross products to solve that one. So we get 16x equals 360. And then 360 divided by 16 gives us 22.5. So we'd say 22.5 tablespoons. In our last example, we're going to use a scale model. So an architect creates a scale model of a school. The school is 50 feet high. The ratio of the model to the actual school is 1 foot to 75 feet. So right there, that's our first ratio. We're going to estimate the height of the model. So I need to use the ratio that I was given as their scale, 1 foot to 75 feet. That's one side of my proportion. The question says, what is the height of the model? Well, 1 foot is the model height, and the 75 feet is the actual height. So if we were trying to find the model height, that h is going to go on top. And the actual height of the school is 50 feet. So that goes on the bottom. We'll use cross products to solve. 1 times 50 equals 75 times h. 1 times 50 is 50 equals 75h, and then you divide 50 divided by 75, and you're going to get 2/3. So the height of the scale model is 2/3 of a foot, which could also be given as 8 inches. In checkpoint number 3, we're going to change that scale of the one that we just did from 1 to 75 to 1 foot to 100 feet. Again, scale to actual. And we want to know what the height of the model would be. Well, the school is still 50 feet tall, so we're going to set that equal to x over 50, because the actual height goes on the bottom. Using cross products, I get that 100x equals 50. Divide both sides by 100, and you get that x equals a half a foot, or you could say 6 inches. And that concludes lesson 3.6.